Hello. Today we will be cooking a steak. And in order to cook a steak, we need a recipe. So first, we will allow the steak to be at room temperature for 30 minutes, then distribute salt and pepper over the steak evenly, then heat a large skillet over high heat, add olive oil, and distribute it evenly over the base of the pan. However, before we cook the steak, some reactions occur. Many people believe that the red coloration of steak before it is cooked is because of the blood inside. However, most of the blood is drained from the meat at the slaughterhouses. The red liquid you are seeing inside of the steak is a mixture of myoglobin and water. Myoglobin is an oxygen-iron binding protein that conserves oxygen in muscle cells. It is very similar in function to hemoglobin, which does the same thing in red blood cells. Because the steak is exposed to oxygen and therefore oxidizes, the iron molecule changes form and turns the myoglobin into metmyoglobin, thus turning the uncooked meat brown. Lastly, to cook the steak, we add a seasoning to the steak before we cook it. Since the steak is filled with moisture at the time, the seasoning absorbs the moisture through the process of osmosis. This is because the water moves from a high concentrated area of water to a low concentrated of water. Ergo, the water from the moisture transfers into the seasoning and then dries out of the steak.
During the process of cooking, red meat experiences a discoloration due to a single protein within the meat, called myoglobin. Myoglobin is the previously discussed iron and oxygen binding protein found in the muscle tissue of most animals. During cooking, however, myoglobin also causes the browning of the outside of the steak due to the oxidation of the iron atoms within the myoglobin. Before cooking, the oxidation level of the iron atoms within the myoglobin are +2, and they are bound to a diatomic oxygen molecule. At this state, the meat is still red. When exposed to heat, the iron atom will lose an electron, resulting in a +3 oxidation level. At this moment, the meat will gradually turn brown. If white meat was being cooked, rather than red meat, the meat would brown much less due to the low content of myoglobin in its muscle tissue. As the pan absorbs the heat from the stove in an endothermic reaction, the meat starts to develop its flavor through a reaction called the Maillard reaction. As the sugars in the cut of meat start to reduce, the Maillard reaction occurs when the denatured proteins on the surface of the meat recombine with the sugars present. Like caramelization, the Maillard reaction is a non-enzymic browning of sugars. The brown exterior and flavor of the meat can be attributed to this reaction. The Maillard reaction produces hundreds of different products, a small subset of these being known flavors and aromas. In meat, the Maillard reaction produces chemicals such as thiophene and furans, giving the meat its distinct flavor. This reaction occurs at around 300 to 500 degrees Fahrenheit, which is about the peak temperature of our pan during cooking. The chemical specifics of the Maillard reaction are quite complex. However, the process can be characterized as a carbonyl group of sugars reacting with a specific amino acid group to produce a mixture of molecules that give off a specific flavor or aroma.
Next, we will reduce the heat to medium-low, add butter, thyme, and garlic, the whole herb, not diced. After that, we will tilt the pan so that the butter and oil pools. And then we will baste the steak with a mixture in order to maintain the steak's moisture. And lastly, we will remove the steak from the pan and leave it for 10 minutes to reabsorb the juices.
Au jus is a popular sauce eaten with steak that is made from the pan drippings of the rendered fat from a cut of meat. In our stoichiometry problem, we will calculate the amount of servings of au jus that is created from our 32-ounce New York strip steak. The experimental amount of juice created from cooking was calculated to be 1.2 cups. This is not the total yield of pan drippings, because we must still account for the contribution from the melted butter that was added during the cooking of the steak, which was 1 tablespoon. 1 tablespoon is equal to 0.0625 cups of melted butter. The sum of these values gives us 1.2625 total cups of pan drippings for one 32-ounce New York strip steak. Now we must calculate the amount of au jus we can create from these drippings. Most recipes for au jus call for about 1/3 of a cup of pan drippings in order to produce 2 1/3 cup of au jus. These 2 cups that are not from the pan drippings are a result of added beef broth that are added to enhance the taste of the au jus. We have now calculated how much au jus we can make from one steak. However, we have yet to calculate how many servings this equates to. To do so, we must determine how many cups of au jus are usually used to accompany meat. This value seemed to be about 4 tablespoons of the au jus, which is served to the side of the meat. Thus, to complete our problems, we converted 4 tablespoons into 0.25 cups per serving and placed it in the denominator to cancel out with the previous representing the total pan drippings. When completed, it is seen that one 32-ounce New York strip steak can produce 35 servings of au jus.